With this video, I would like to show you how to determine the least squares regression line, or the line of best fit. Remember that the equation of the least squares line is always going to have the form y is equal to a plus bx, where the constant a is the y-intercept and b is the slope. Determine the least squares line for the data set given below, x and y, and we've got 1, 2, 3, 4 different points. So n is equal to 4 points. So if we did a scatter plot, we would end up with 4 points on our scatter plot on a Cartesian plane with x and y being the axes. Now, again, this is a statistical data set, so we're going to be going into mode, and we're going to choose 1 for stat. And in this case, we have a linear relationship, or we're searching to see if this is how strong the linear relationship is. So we'll select 1 for linear because we have two variables here, and we're going to start entering in the data points. So the first point is 3, 6. So that's x is equal to 3 and y is equal to 6. So we're going to key in that data point. So 3 for x. So we're going to press the XY key. Now you'll notice here that I've got an XY with a comma. So I'm going to press that button. It's right above the data key. 3, comma, and the next variable y is 6. And now I'm going to press data. So after I finished entering in the coordinates for the point, I'm going to press the data button, and you'll see that data set is equal to 1. That confirms that I've entered in my first data point. My second data point is 5, 11. So x is 5, and I press the comma button, or the XY key, and then I press 11, and then I press data. So there's my second data set. And now I'm ready to enter in my third point, 7, 15. So 7 is my x value and 15 is my y value. And I press data when I'm finished. And now I've got my third point in, and now I'm ready to enter in the fourth point. So 11 is my x value and 20 is my y value. And once I've entered in the 20, I am now ready to enter data. Now let's use the calculator to come up with some of the values that we would like to obtain. For example, the average x value and the average y value, as well as the equation. So if I search the keyboard or the calculator buttons, I can see that the average x value is right above the 4, and it's green, so I'm going to press alpha 4, or alpha x bar, and the calculator tells me that the average x value, and I have to hit the equal button to get that value, is 6.5. So the average x value is equal to 6.5. Now let's get the average y value. And the average y value is obtained by, you'll observe that the y bar value is right above the 7. It's green, so I'm going to press alpha y bar and hit the equal bar. And we end up with an average y value of 13. So the average y value is 13. So in other words, if I added up all of the y values and divided by 4, I would have an average value of 13. Now for the equation. For the equation, I know that the equation has the form y is equal to a plus bx. And so what I need to do is get the values of a and the values of b from the calculator. And you can see that they're all in the same neighborhood here. A and b are given right here above the left parentheses and the right parentheses, and they're green. So I'm going to press alpha a is equal to. So the a value is 1.8, we'll round that off to 3 significant digits, so 1.86. And alpha b is the slope, if you recall. Press the enter button, is 1.71. So that means that the equation can be best given by y is equal to a, which is 1.86, plus 1.71 times x. And so we can come up with the best fitting, or the least squares regression line that would satisfy those set of 4 points. And now let's carry on and come up with some other values. The correlation coefficient, that would be the r value. And that r value is right above the division operator. You'll see that there's a small r there. It's green, so I'm going to press alpha r. That's called the correlation coefficient, and the correlation coefficient is always going to be a value between -1 and +1. The closer you are to +1 or -1, the less the degree of scatter is on the scatter plot. the less variation there is on the data points away from the regression line. So in this case, our R value is 0.985. So the R value is 0.985, and so on. And another number that's important is the coefficient of determination. And the coefficient of determination is simply determined by R squared. So I'm going to take the R value and square it. And so we've got R squared, just hit the X squared key and hit the equal bar. R squared is always going to be a positive number, and it's going to be between 0 and 1 because you're squaring a number that's between -1 and +1. So when you square it, you'll always have a positive number. And in this case, R squared is equal to a value of 97% or 97.04%. And so these are some of the numbers that you will be discussing in your follow-up statistics course.